Hey there, CJ Math students. Welcome to homework number 9 using the commutative property and associative properties. If you're absent or just need a refresher on how to do this, this video is for you. So for the commutative property of addition, you'll notice that you can basically change the order of any addition problem and it's still equal the same. Hence 2 plus 3, which is 5, is the same thing as 3 plus 2. For the associative property, you can change the grouping of any problem and still get the same sum. So if I add 4 plus 2 first, I get 6, and add 1, I get 7. But if I add 2 plus 1 first, I get 3, and then I add 4, I still get 7. Notice the order of the numbers did not change, but the grouping, the parentheses, in each problem changed. It just kind of shifted down one. So that's the associative property. So we can use these two properties as well as our ability to convert between fractions and decimals and our knowledge of the additive inverse, opposites equaling 0, to make really complex problems a little bit easier. So take a look at number 1. First, you're always going to KCC whenever you see subtraction. So 4.6 minus a negative 10 minus 3/4 becomes 4.6 plus 10, and then you might have to KCC a second time. So that 10 minus 4 3/5 becomes 10 plus negative 4 3/5. And now it's your job to spot things that are possibly equivalent. So notice 4.6 and negative 4 3/5. Well, if you convert negative 4 3/5, you just get negative 4.6, right? And so once I've done that, I can use the commutative property. I can put the 4.6's next to each other. Why am I going to do that? Because 4.6 plus a negative 4.6 is 0. And then 0 plus 10 is just 10. So that really complex problem, all I had to do was notice that the 3/5 is the same thing as 4.6. Use the commutative property to put stuff next to each other to have it cancel out because of the additive inverse, and then all you do is get 10. If you take a look at 2, again, you're going to want a KCC, so 5.1 minus 4 4/7 becomes 5.1 plus a negative 4 4/7, and then you might have to KCC a second time, so that negative 4 4/7 minus 5 1/10 becomes negative 4 4/7 plus a negative 5 1/10. And then hopefully you'll notice again, hey, wait a second, this 5.1 and this negative 5 1/10, those are the same thing if I convert negative 5 1/10 to negative 5.1. And then once I do that, let's just use the commutative property again to put my 5.1's next to each other. They cancel out to 0 because of the additive inverse, and 0 plus negative 4 4/7 equals negative 4 4/7. Some of you might have been like, oh man, I gotta find a common denominator between 7 and 10. No, sometimes you can make the problem easier if you can use the commutative property and use fraction decimals equivalents, right? Take a look at number 3. You'll notice, again, KCC right off the bat, negative 5 1/5 plus 3.1. Notice I don't have to KCC a second time because that next one's a positive. And then I got negative 5 1/5 and 5.2. Oh, if I just convert this negative 5 1/5 to its decimal equivalent of negative 5.2, look at that. Again, I use the additive inverse by putting, or see, the commutative property of addition by putting the 5.2's next to each other. Those cancel out because of the additive inverse, and I'm left with 3.1. Sometimes it's a little bit harder to see, such as your eighths, right? So no KCC in this problem. But if you take a look at 32.875 and negative 12 7/8, if you memorize your eighths, 0.875 is 7/8. So notice this time you can convert them all to fractions, you can convert them all to decimals, whatever you're more comfortable with. I decided to convert them to fractions this time around. And then I decided to use the associative property, and I broke apart the fractions group next to whole numbers. So I decided, hey, let me put these whole numbers next to each other. So 32 plus negative 12, and then let me put these fractions next to each other, 7/8 and negative 7/8. Remember, this is a negative 7/8 if it's got a negative whole number. These 7/8 cancel out, that's 0, and then I just got a DSSM problem of 32 plus negative 12, which is 20, right? And then the last one I did in class with you guys was this one, this 3 1/6 plus 20.3, got a KCC here because we have minus a negative, so it becomes plus a positive. And then again, you might be freaking out because you're like, oh, the 1/6, I don't know, but what about if you saw, hey, we could maybe make a whole lot of this if we put 5/6 and 1/6 next to each other. And that's exactly what I did here. I put the 3 1/6 plus 5 and 5/6 next to each other. That gets you 8 and 6/6, which 8 and 6/6 is actually just 9. And then 9 plus 20.3 gives you 29.3, right? I'll let you take care of the last one. I did one more on the back. It was 7. This is called borrowing from a whole. To make your life a little bit easier, I'll write it out here. Borrowing from a whole. And basically it's when you have this whole number and you're trying to add negative or subtract, you can break up 80 and rewrite it by looking at this denominator. So I'm going to break it up into 79 and then a 1 whole, which it's determined by that fraction right there, which is 7. So 7 over 7, because what is that? That's still 1, and 79 plus 1 is still 80. So I haven't done anything to the 80, it's just rewrote it. I did that so that I could then use the commutative property of addition and put the whole numbers next to each other. So the 79 and the negative 22 and the fractions next to each other. The 7 over 7 and the negative 4 sevenths, right? So 79 plus negative 22 gets you 57, and then 7 sevenths plus negative 4 sevenths gets you 3 sevenths. They're both the same sign, so you can just slap them together. It was a tricky one, so let me try it again on this one over here. So 10 should turn into 9 plus, again, you're just going to look at that fraction right there, which is out of 5. So 9 plus 5 fifths, excuse me, plus negative 3 plus negative 1/5. And then, use your commutative property to say, hey, I want to put the whole numbers next to each other, and I want to put the fractions next to each other, right? So that should be 9 plus negative 3 plus 5 fifths plus negative 1/5, and I'll let you take it from there to solve. That's it. Call me if you have questions.